Now, why the boiling point get decreased in case of minimum boiling azeotrope or showing solution, non-ideal solution, showing positive deviation, and why the boiling point of the solution showing negative deviation get enhanced, maximized on mixing the two components. For this minimum boiling azeotrope, that is 95% ethanol solution in water by volume, what we see. See, here is mole fraction of water is 0. So it is representing the vapor pressure. This is the graph between the vapor pressure and the mole fraction. Here the mole fraction of ethanol is 1 equals to 1. Here mole fraction of water is 1, but the ethanol is 0. That means it is representing, this is the vapor pressure of pure water, P0 water, and this is the vapor pressure of the pure ethanol. So when you will join this line will represent the vapor pressure of solution of ethanol and water. If it is behaving like an ideal solution, the line should be like this. But what we observe practically, on mixing 5% water in 95% ethanol, what we see this is pure ethanol, and when 5 ml of water is added and 95% ethanol, what you observe, that vapor pressure is maximum. Okay, plot the another graph. This graph is between the boiling point T and the mole fraction X. What we, on observing the, comparing the two, what we find, that this is here the vapor pressure is maximum, and corresponding to this, the temperature of the mixture is below the temperature of the ideal solution. Boiling point of pure ethanol is 351.5 Kelvin, 351.3 Kelvin. And you know well that boiling point of pure water is 370 degrees Celsius or 373 Kelvin. So when the two solutions are mixed in the ratio 95% into 5%, what we see, the moment the composition reaches to 95%, the vapor pressure is maximum here, and the temperature corresponding to that is here. That means this is the boiling point of the mixture of the binary liquids. This is, so what is this temperature? It is 351.15, which is below than the boiling point of the two component. Boiling point 351.3 for ethanol, 373 Kelvin for water, but for this binary solution, the boiling point is 351.15 Kelvin, which is below the boiling point of each component. That's why we call it minimum boiling azeotrope. Similarly, compare why a solution showing non-ideal solution or fixed composition showing negative deviation from Rod's law is called maximum boiling azeotrope. Let us examine it. See, this is the graph representing the vapor pressure against the mole fraction. Here, moles of water is 0 and moles of HNO3 is 1, because we know example of azeotropic mixture showing negative deviation is 68% aqueous solution of HNO3 by mass. That means 68 gram of HNO3 and 32 gram of water. When mixed together, it is forming the azeotrope, maximum boiling azeotrope, or azeotrope showing negative deviation from the Rod's law. So what we see, when the composition of HNO3 becomes 68%, the vapor pressure is minimum. This is the list. Here, it should be, for in case of ideal solution, the vapor pressure should be here. But what we find, the vapor pressure on mixing 68 gram of HNO3 and 32 gram of water comes down to this. This is the lowering of vapor pressure. It is showing negative deviation. Now, what happens? What is the plot? Another graph between temperature and the mole fraction. At the same composition, what we find that a boiling point of pure HNO3 is 359 Kelvin and boiling point of the pure water is 373 Kelvin. But when the composition of HNO3 and water becomes 68% and 32% respectively, the boiling point corresponding to this minimum temperature is here, which is greater than the boiling point of each component. It is 359, it is 373, but here 393.5 Kelvin, which is much higher than the boiling point of each component. So it is maximum boiling azeotrope. And what here in this case, minimum boiling azeotrope, the vapor pressure is above, so boiling point gets lower, and this what we can see here clearly, that boiling point of pure ethanol is 351.3, boiling point of pure water is 373, but the boiling point of a solution formed by mixing 95% ethanol and 5% water by volume, the boiling point of the solution becomes 351.15, which is below than the boiling point of each component. So it is called minimum boiling azeotrope. So with this, my part gets concluded so far. Dilute solution is concerned, and after this there is a part called colligative property, which has been already started by the learned teacher Dr. A.K. Mehra. So in the next class we will discuss about the solid state. And the initial part, which is related to class 11th, has already been covered by learned teacher Sri Niranjan Singh. We will continue from there. Thank you.